Is my screen visible?
Yes.
Perfect.
Yeah.
Yeah. Hi, all. Once again, hope you're having a lovely evening. A very warm welcome to everybody who is here for the WaiPRACTICE showcase. Yeah. So for today's agenda, I'm going to walk you through Women in AI and what is WaiPRACTICE. And then we have the main course for today, which is the presentation from 3 incredible groups. And then we'll have a closing notes with a bit of information sharing as well. So Women in AI, we are a non-profit organization, and our key mission is to increase and uplift female representatives across various sectors and job profiles, particularly in AI. So we have a number of initiatives right from ideation till in execution. And our focus is mostly on technology, which is like AI. I'm going to admit people. Yeah. And our community has a lot of presence across the globe with over like 150 in over 150 plus countries and 60 plus ambassadors and a whooping 8,000 plus members. So I would say it's a very much fast growing community across the globe. And so WaiPRACTICE is one of our educational initiatives where participants come and, it's more of a hands-on experience from a core technical perspective. I would say it's a playground where people who are interested to learn, like AI and new stuff in AI, and the industry and domain experts come together, grow their knowledge, like share their best practices, and also like collaborate together in an 8 weeks program to give you a glimpse of what happens in that 8 weeks. So on the week 1, right, the participants and the mentors come together and they decide on a use case that they'll be working on. And if relevant, they'll decide on a data set as well. And on week 2, they'll start to explore the data set and have a good grip on the problem statement that they are working on. And on subsequent weeks, for example, on week 4, they'll be building a POC to what they want to achieve at the end of the program. And on week 6, mostly they would have finished, like their main objective and start to document their results. And on week 8, wrap up everything and get ready for the showcase day and share all the deliverables. And today we are on the showcase day. So today we have 3 incredible groups which worked meticulously for the past 8 weeks. I'm very much impressed by the work they have done, like apart from their daily routine of going to office and studying, they have also like put a lot of efforts into this, learning a new thing. And a special mention and thanks to all the wonderful mentors here for mentoring for the past 8 weeks as well. Thank you so much. So without further delay, I would like to invite Sola from Group 1 to showcase your project. And last but not the least, so the theme for this cohort, right, it's generative AI. So all the projects that you'll be seeing today will be aligned in that theme. Yeah. Thank you. Sola, do you want to share your screen and present? I think you're on mute, Sola. Probably if you're on mute.
Can you hear me now?
Yeah, you are. Probably you can
I
put in
need
the presentation mode, but if not, you can continue. Yeah, over to you.
Okay. Hi, my name is Soyikon Shitu. I'm one of the group or former group 1 of the 2024 June cohort. And I'm here to present the project we had. Is a chatbot for hobbies. This is a generative AI hobby where we created a chatbot in 2 forms. The standard generation from the large language model from Google AI, and we use the RAG, which is a retrieval augmented generation. This idea of the chatbot was actually muted from a former colleague of mine. Sorry, there's something wrong with the screen. Can you see my screen now? It's blank here.
No, I think, yeah, we're able to see your screen.
Okay, was muted from a former colleague of mine, Kamisha, when she had this idea that we should generate a profile solution for people who don't have idea of what to do when they have their leisure time. Now, my background, I come from a non-technical background. I'm a chartered accountant, and I kind of upskilled in data analytics. I learned some programming languages, the R and the Python. And then I learned about machine learning and neural networks. And now I have the opportunity to learn artificial intelligence with this hands-on project. I'll be talking about the project motivation, which I just did, an overview on the generative AI, brainstorm and data selection. I'll try and give you a few demonstrations of the project reproducibility, the challenges I faced, the key learning outcome and future works to do, and then appreciation. Now, as I said before, the project idea came from the former member, which is Kanisha, and with a zeal of providing a solution to those things. As generative overview of generative AI, AI on its own, it's a deep learning technique, which is a subset of machine learning, whereby machines are actually tuned to emulate human brains to predict or classify, for example, by learning patterns from the supply data from which those models were trained on. An example that we all know for facial recognition, Alexa, Google Assistant. Now, when this artificial intelligence is actually extended to be able to create new content like a human being would, then it's what we call a generative artificial intelligence. This is just a summary of it involves a lot of things, but basically the computer system would answer users' prompts, questions, and then the answer will be fed or guided through what that prompt is, what the user's question is about. So for this project, which is RAG based, we had a CSV that was an external source. And the system we actually sent will go through the CSV, depending on the question the user sends, will go through the CSV and retrieve relevant information, pass it on through a vector similarity search, and then pass it on to the large language model, which is the Gemini Pro that we use in this project to generate the answer for that question. This is a pictorial show of what I just explained now. The generative artificial intelligence that we used, Gemini Pro, is actually multimodal. It had audio, data trained on it, images, video, text. But if you look further down where the retrieval step is, this is basically what I just said now. When you have the large language model, in our own case, now Gemini Pro, and the user sends a prompt, which is basically a question, it gets fed onto this model, the Gemini Pro, and then it generates answer for that standard equation to give the user an answer. But for the RAG, the retrieval augmented generation one, we have this vector database, which had already been embedded and converted into vector, which is like just numbers for the system, for the computer system to understand. So when the user sends a particular specific or domain specific question, the system will go to that vector database using similarity search. In our own case, is a hobby list CSV, and then retrieve relevant information, send it back to the large language model to send the retrieved information to the large language model, which is Gemini Pro in our own situation, and then to generate the answer. This on the right side is just the pipeline. So the CSV we use is the from Cargo, is a clean CSV, and it's called Comprehensive Collection of Hobbies by Arjun Raj. This is just a snapshot of the steps to do if you're going to use Google AI, which we use in this situation to build the chatbot. You get your Google API key here from these steps here, because those are the things you use for authentication for you to get all your chatbot going. So you click on the create new prompt, set the run settings on the right side, which is here. You rename your model, whatever name you want to put, to give it a description. Click save. Like I said, we use model Gemini Pro, and you tune it. For a standard RAG model in this Google AI is basically the same thing. We uploaded the CSV into this, this is Google AI, to the Gemini Pro to tune it. And then you send in your user prompts. For example, since this is a general question, it's not specific to the CSV. So I'm a 65-year-old. I don't like the sun. I don't like challenges. What hobbies would you recommend? And to give you this output of all those ones. Now, for this one, this is the standard one. I'll show you the one for the RAG. But before then, I want to give you something for the inbuilt model that we're talking, the Gemini Pro. It has a limitation. It cannot give you a system message. So for us to give the system message, we had to make a code, a trick, and convert the system message to be true, which was what I did here. And then you input the system message. For example, the system message is basically instructing the computer on how to behave, on what to do when the computer receives the prompt of the user. So in this situation, I said, the computer is a hobby expert. The name is Cousin. Should be polite at all times and answer correct as best as you can. Then the user's prompt is say, what can I do indoors, but also active? And then you have this is the output. Hello there, my name is Cousin. As instructed, I'm pleased to help you with indoor activities. It's being polite and also active, and I now gave you the few ideas of what to do. But back to the main thing of this one, which is the RAG base. I'll have to show you a demonstration of what we did. So for that, I'll go to the Colab notebook. Here, I've already set the running. This is the retrieval augmented generation. This is split into two, using the agentic RAG and the standard RAG. The standard RAG was the one I just showed you. So I'll show you the agentic RAG. Now, we loaded the hobby list CSV that I told you as DF, and then we'll go ahead and create the agent like that. Note this temperature. The temperature is set to 0. The reason being that we want it to actually retrieve information from this hobby list CSV, which is the external source that the computer will now go and fetch from. So we gave it the large language model, the Gemini Pro, and the hobby list CSV. So you run the agent with the user's question, prompt question, and that will be, I gave it which 10 hobby names are duplicated in the hobby name. If you look up where we reviewed the CSV, you can see that it has just 2 columns, the hobby name and the type. So here we are going to run it and you'll see what happens. You can see that it has is actually giving you the thinking process. The computer is giving you a thinking process. Just I should use the duplicator function to find the duplicator values in the hobby name column, which I showed you before. And this is using it. So it is from the DF, which is the user and the name where we loaded the hobby list, and using this hobby name column and using the
Sorry,
duplicator
Solar, sorry
function.
to cut you, sorry to interrupt you. Probably, are you sure, do you want to show your tool? Because we are only able to see your PPT.
Oh, really?
Yeah. So just figured out if you want to show the other.
Okay. Let me just share again, okay?
Yeah, sure. You can share your whole screen if that'll work for you.
Yeah, that's what I thought.
Mm-hmm.
Can you see it now?
Oh, yeah, perfect. Go on.
Oh, great. Okay, so let me just quickly run back to what I said. So I loaded the CSV into a variable DF, and I checked if it was loaded correctly. It has two columns, hobby name, type, and those are the hobby name. So now to create that agentic RAG, we have this code snippet, and I set the temperature to be 0 so that it can actually retrieve information from this external data set, the hobby list. And I used the Gemini Pro, which is the Google large language. So you run it with this user's prompt. I said she gave me 10 hobby names because I didn't want to overload the system. 10 hobby names to duplicate it in this hobby name column. And I ran it to give me this thinking process. That's the beauty about this RAG. It will even give you a thinking process that will enable you to be able to query and, fine tune to be sure if the system is thinking. And he said, look, I'm looking for, you asked me to give you duplicated hobby names. So this is the thinking. And he went to get it from that hobby name column, and he gave us this as the duplicator. So from all this thinking, you could get the final answer and refer to get other, which is different from the standard RAG in a way. I gave it another specific prompt. What category level exists in the CSV? When we run that, it's going through the executor chain again, and then you can see the thinking pattern. As you use the unique function found in the type column, which was the second column we saw earlier. And from there, it had this code snippet to get all this. So from there, it could actually adduce that this is the final answer to give, and that's how you could get it. So from here, you could see that, okay, fine, it's actually going through the external source and not just a general thing. So I decided to give it a general question. I'm 65 years old. I don't like the sun. I don't like challenges. What hobbies can you recommend? So from this prompt, you can actually get it from either from the large language module or from the specific. But when you run this one again, you'll see that it's actually came from the specific. And how do I know that? It says it's filtering the data frame, which was what we did before we made it when we loaded the hobby list. And it actually gave us this one. See, the hobby name and the type columns is still what we are. So we are sure it went to retrieve the information from the external source, our hobby list CSV, and not just from the general. And that was because we set the temperature to be 0, which is something amazing, because at least it's part of what one could have done if we were to do the evaluation. So back to my presentation. Are you still seeing my presentation now?
Not
Or
yet.
still not sure?
Probably, do you want to share again?
Sorry about that. It's just.
No worries at all. You're good.
Mhm. Is it showing now?
Yes, yeah. Just a heads up that we are running out of time.
Oh, okay. So that is basically, so I had some challenges, not many. It's mainly about the OpenAI key, and so many error messages which we tweaked and resolved. But the main thing was the rate limit error, which we couldn't do anything much about it. And because we had to buy tokens and we are trying to use the free tier. So that was why we chose the Google API. We gave us better tokens to use. And then the navigation challenge of the PyCharm and GitHub, which was okay. So the key learning outcome was just for me to be able to build a lightweight chatbot using both the inbuilt model and the RAG, and to navigate PyCharm and GitHub. However, for future work, because I ran out of time, I wasn't able to do the evaluation for accuracy. So it's something that I'd like to do, and to be able to check the hallucinations, if anything at all, experiment on prompt engineering, and incorporate guardrails for security purposes. Thank you very much, Mithra and the Y group as a whole. I'm grateful to Nishta J, my mentor, for all the tutelage and guidance and everything. And thank you all for watching this presentation. It's a short one, but I hope I was able to impact to you what I did in the 8 weeks. That will be all for now from me. I'm ready for questions now.
Yeah, wonderful presentation, Sola. Like great work. And yeah, open to the audience. Do you have any questions for Shola? Perfect. Yeah. Thank you so much, Sola, once again. And I now invite group 2, Chloe and Sarah, to present your work.
Great, thank you so much. Thanks, guys. Hi, how are you? I hope you guys are doing well. I hope the weather is nicer where you guys are than where I am. And thank you, Sola. That's a tough act to follow. So hopefully I can continue the great work. I'm just gonna share my screen. So, go. Everyone see my screen okay?
Yeah.
Perfect.
Okay, perfect. So yeah, I'm the representative of the second group from the WaiPRACTICE this year. My name is Chloe, and our tool is also using a RAG framework to create a study tool, which we have provisionally named StudyPal Geo. So the outline for this presentation is just to have an introduction, so meet the team, talk about the summary of the project and why we chose it. Then we're going to talk a little bit about the process, so how we went about the process and what we used. And obviously, as what always happens, any issues that we came across. And then we talk about our provisional results and maybe some extensions, and then we'll have some time for questions at the end. So just to introduce the team, I'm Chloe. Hopefully you can recognize me from the picture. I am actually an English language teacher. And a few years ago, my background is in science, so I was trying to find kind of a mixture of that. And then I discovered natural language processing. So I've been trying to move into that area for the past 2 years. And I'm starting a master's in September in natural language processing. So this project was really, really a fantastic opportunity to have, a whole workflow before I start my master's. And Sarah, who I don't think is here, or maybe she is, she is a healthcare data analyst. And I know that she is especially interested in AI, anything to do with kind of the healthcare area and responsible and, ethical AI. So just a quick summary of the project. We decided to, we really wanted to try utilize and leverage large language models. And, the theme is, of course, generative AI, which Sola has explained in depth. So great, I can kind of skip past that a little bit. So we decided to create a pipeline using a RAG framework, which is to make sure it's specified to the task. I will talk about this a bit more as we go through. But we wanted to create a useful tool for students that is catered to whatever exam and whatever level that they are doing. So how this differs from, say, just Googling or, just, using ChatGPT is sometimes certain exam boards have specific answers. So I even know from my own point of view with the Irish Leaving Certificate, in the junior certificate, something about the I wasn't technically true, but it was true for the exam. So you want to make sure that the answers you're getting are reliable, but that they're catered to the exam that you're sitting. So rather than getting a paper on college physics or something like that, you're getting something that's related to the physics, I don't know, GCSE exam or something like that. So I'm going to talk a little bit more about that. The other aim of this project was to use completely open source and free tools, which proved to, I think, be one of the most difficult parts of the project. It's in its early stages. You know, I will talk a little bit more about the results we currently have and some plans that we have to improve it. So as I said, we wanted to reduce the stress that we all have, I'm sure, have felt in the past at some point. You know, if you end up, sometimes you can end up in this endless cycle of Googling, and as I mentioned, ending up on these random pages of study guides and less stress, more success, you know, all these sorts of things. So we wanted to provide one tool that is reliable, and you know it's going to give you information that you need for your exam, not for any sort of other exam. So we chose GCSE Geography as our exam. And so it should provide explanations that are to a GCSE level, not college, not postgraduate, anything like that. And we chose this project specifically, as I said, I'm studying NLP. I've done sentiment analysis projects before, but I haven't actually worked with large language models a lot. So this was a really, really useful hands-on project that allowed us to, you know, really get to understand how to apply a RAG framework and understand how to work with large language models, you know, and the issues we came across there. So the first thing that we needed to do was identify what kind of knowledge we are going to use to feed in with the RAG framework. So obviously it has to be accurate. Yeah, there's lots of resources for exams online, some of them more accurate than others, has to be reliable. And we also have to be able to access it. So here is an excerpt of the knowledge database that we used. I have the link to where we got that from at the end of the presentation. We explored a number of different materials. So originally we were going to look at website scraping with BBC Bite-Sized Geography. So this is a really good website through the BBC that allows, you know, explanations. We looked at exam papers and marking schemes. The biggest issue we found with that was the exam paper and the marking scheme, because of the format of it, it was too awkward to feed in. We would have to kind of edit it or, you know, merge the two together. So they were kind of separate with the answers not really answering the question. So it would have been too hard kind of to feed in. We also found some official terminology booklets, topic booklets, but we ended up focusing on revision guides that were provided by schools. These were in the form of PDFs. So currently our project only works with a PDF knowledge database. And you can see the example here of what we chose. So as I said, we try to keep everything as open source and collaborative as possible. So we used Slack for communication for our group meetings. I think we saw the timeline earlier that we had all the group meetings. So we aim to meet weekly with the team and then also weekly with the mentor as well. So there was around two meetings per week, if possible. We used Google Colab. So this is what we ended up using kind of to share our notebooks. It ended up just being the easiest way to kind of, okay, here's something I've edited, to share back and forth. And it also has the added bonus of having a GPU uses. My laptop has a shockingly low CPU. So, you know, this enables us to actually get the project to run. But again, that had its issues as well. We use Google Doc for sharing notes, and if we found papers or resources, we could share the links there. We ended up using Google Drive to save the embeddings, which I will come back to later, GitHub for publishing all our work, and we also use Google Slides to create this presentation, so it's quite Google oriented. So the first main issue we had, obviously, was to understand what a RAG framework is. Was explained in depth earlier, so I'm just going to do a quick overview again. So this RAG framework really allows us to use the LLM while making sure that it's, you know, catered to the exam, it's contextually aware, it's not producing anything that isn't related to the knowledge database we fed it. And it's just to make sure that it's a reliable tool. So I've broken up the process here into 3 different parts. I mean, it could be broken up further. So at the first stage, we have your input. So this is where the user will input their question. In this project, it's going to be a question about something to do with geography that comes up in the GCSE exam. So I don't know, in this case, the Hadley cell or plate tectonics, water cycle, all these sorts of things. Then what we do is we have already fed it this knowledge database that is the relevant data that relevant material it should generate its answer from. That has been split and chunked and created with embedding. So what's really cool about the RAG framework is it makes sure things are semantically related, which is absolutely fascinating to me. So they do that by creating embeddings. And then what we're able to do is use a semantic search, which I think was previously mentioned. So it matches the embeddings from the chunk from our knowledge database to the embedding of the user query. So it really makes sure that our question is answered semantically from the knowledge database. And as I mentioned, our database was built from a GCSE revision guide that was provided by a school. And then it uses the LLM. I'll talk about what LLM we chose in a second. And that generates the answer using the knowledge database, but it is able to create a coherent answer using the power of the LLM as well with the knowledge database. So different technologies we used, what we were able to do. So we use LangChain. LangChain is the library that really allows this project to happen. We couldn't have done it without LangChain. So this is kind of the platform where we can access all the different tools that we will need. We used Hugging Face, which is again a way to help build models, especially for machine learning models. So we use that to get our embedding model, and we also use that to access our LLM. So our LLM could have been accessed through the Google Studio Solda was mentioning, but we decided to access it through Hugging Face because we were already using that for the embeddings. So we chose instructor embeddings, which are a type of sentence transformers. So that is what converts our knowledge database to the embeddings. And also we then use the Gemma LLM, which I'll go into in a bit more depth. And we use both of these through Hugging Face. As I mentioned, obviously you have to have a Hugging Face key or a token as well. So that is something to note as you're doing this project. And then we use Feist, which is actually created by Meta. So we wanted to try find something that was free to use. So we found Feist, which is the vector database that allows us to do the similarity search and create, it's the vector database for that. So as I think I've kind of mentioned throughout, some of our biggest issues was finding a way to store the embeddings. So we looked into various different ways. What we ended up doing within the time frame was just using Google Drive. I don't know about your Google Drives, but mine was nearly full. So it does take up a lot of space. So to run it once took about 4.6 gigabytes of the 15 free gigabytes. So to be aware of that. I think the first time we tried to run it, we had a much larger database. We had a bigger LLM, and it just would not. I think it nearly took all of my Google Drive. So we had to streamline the process, and that still took up about 4.6 gigabytes. So it's definitely something to notice. But it was a free alternative. You just have to, be aware of that. And again, finding free tools. So we ended up using Hugging Face, and we use Gemma as our LLM. As Gemma is kind of the Gemma 2B is part of the Gemma family, and it's an attempt at kind of using the power of an LLM, but on a much smaller basis. So it allows us, a lot of the other LLMs that we tried, you just could not run on the GPU that we had with the Google Collabs. This was one that ran, and it was, it does the job. And again, the powerful GPU, the CPU, we ended up using Google Collabs T4 GPU, which was really useful. It definitely reduced the runtime than trying to run it locally on like Jupyter Notebook or anything like that, but it does have a daily time limit. So that's definitely something to keep in mind, that when you are trying different things in the project, you have a limited window to kind of do that. But again, it is free. So the key learnings we had from this project was, both of us went in not knowing about a RAG framework. So we've definitely become very well acquainted with it, how to use it, and how to, with prompt formatting, how to generate contextually aware answers. we definitely got to know the tools involved in creating a RAG framework, or a chatbot or a QA system. It was definitely an eye-opening experience of creating free open source tool, of using these tools, and how you do have to sacrifice a little bit with the performance of the model if you want to do everything free. I think that's definitely, there's a balance there. Just for the project itself, I think this is where having a mentor was extremely essential, because neither of us really knew anything about RAG frameworks going in. Dividing the tasks was kind of hard because we didn't know how much each of these tasks would take. So having a mentor just for guidance and being able to help us split the tasks evenly was really, really so necessary and needed. And just time management as well, and kind of having a goal and task approach to continuing our projects. And yeah, our final result here, you can see that if you input the question, how does a Hadley cell work? It does generate an answer that does answer the question. So this is where I took the excerpt from earlier. You can see that. I think it requires a little bit more work, but it is definitely in the early stages, and it does, we have made sure that it only answers based off the knowledge base that it is fed. So some feature improvements, we ran out of time, so we weren't able to make a nice user interface. So that would definitely be a future extension. I think we could definitely keep going with hyperparameter tuning. We did look at temperature and found that a lower temperature, because we have the stricter knowledge base, that definitely helped. Maybe using something like single store to store the embeddings. That has a free tier, but because it was a limited free tier, we just stuck with Google Drive. And just further exploration, maybe there are more LLMs that we didn't see. And the idea would be that we would be able to expand this to more topics, subject levels, O levels, A levels, different subjects, music, art, and even other examinations. So the idea is that if we wanted to change it for a completely different exam, there isn't too much to do there. The main thing would be finding the new knowledge database. So I think that's it. If anybody has any questions.
Thank you, Chloe. Wonderful presentation. And again, open to the audience. If you have any questions, please shoot.
Yeah, any questions? I had my 2 coffees today, so hopefully I didn't speak too fast. But yeah, if anyone has any questions. We also have talked about this more in depth in our blog, which you can see on the repository as well. So, and you can see our code as well if anyone is interested. And there's as well where we got the knowledge database from. So, yeah.
Okay, thank you so much. Perfect.
You're welcome.
And over to group 3, I think Shubhangi and Angela.
Okay. Good evening, everyone. Just give a quick introduction to myself. My name is Angela Kinnan. I am in the process of returning to work at the minute, but my background is in theoretical physics research, finance, risk consulting, and most recently I did a master's in data analytics at UCD. And Shubhangi, would introduce yourself?
Hi, everyone. I'm Shubhangi, a data scientist. I have a background in electronics and communications. I also hold a master's in computer science. I really like learning about latest tech, but I have a special interest in understanding the practical implications of that tech in healthcare.
Thank you, Shubhangi. So Shubhangi and I have been working together under Nabonita's guidance on our hate and offensive speech detection model. So we set out with the aim of developing an AI-powered system that would detect hate and offensive speech in short-form text, such as tweets and social media comments. So in this presentation, we're going to discuss 3 different methods that we use to approach the problem. The first 2 are simpler NLP-based methods, and then the third leverages an existing LLM. So why identify hate and offensive speech? Social media has the power to connect communities, but that being said, we're all aware of the issues that come with these freedoms and communications. Identifying hate and offensive speech is very important in maintaining safe online spaces and communities, for protecting vulnerable individuals and marginalized communities, but also for protecting businesses themselves, for helping them to meet their legal and ethical responsibilities, and also maintaining platform integrity, which is important when you want to work with advertisers. The data that we used was initially the Kaggle hate speech and offensive language dataset, which consists of just under 25,000 tweets, which have been classified into hate speech, offensive speech, and neither. So as you can see from the word clouds, there's some pretty offensive language in the tweets. So what we discovered as we were examining the data set was that all three sets of all three categories of tweets did actually contain language which was considered offensive. And also we had a very large imbalance between the hate speech, offensive speech, and the neither category. The neither category only, I think, accounted for less than, I think, probably 10% of the overall data set, which gave us a very imbalanced data set. So our solution that we came up with was to augment with some additional data. And the data we used to do that was taken from Kaggle, and it was the Twitter sentiment data set. So from that, we extracted positive and neutral tweets to ensure that we didn't have anything offensive within that. Then began the process of cleaning the data and getting to know the data better. We did some analysis on things as the Twitter handles that were used, the emojis that were used across the different categories. Then we removed stop words and attempted to remove as much of the additional uninformative text from within the tweets. Then we split our data sets into training, validation, and testing so that we could have a thorough process in analysing our models. So the first model we used was a bag of words model. So the bag of words model you're probably familiar with, but it creates a vocabulary of unique words found in the training set. With each word that appears within the training data, a unique is taken. It's converted each tweet into a numerical vector based on word frequency of each unique word that appears in the data set. So vectors are used then as input for a logistic regression model, which then enables binary classification. In our case, we were just simply looking at hate and offensive and neutral. So the pros of this method are that it provides a really simple method, quick to compute, and it provides a good baseline performance measure when we're looking at more complicated models. However, it doesn't consider the context of the words and can lead to very high dimensionality when you're looking at vectors that are effectively the length of the number of unique words within the data set that can be very long. So we think we were looking at maybe 20,000 unique words within the data. So it also, the other issue with the model is that it has based on fixed vocabulary within the data set. So anything new that comes up in the offensive, potentially offensive, isn't going to be flagged as offensive unless it was present within the training data. So Shivangi, I'll hand over to you.
The second approach we tried was TF-IDF with logistic regression. The TF-IDF stands for term frequency inverse document frequency. And it's an extension of bag of words that not only calculates the word frequency, but takes into consideration how rare and important a word is in the entire data set. So words that are common across the data set are down-weighted, while rare but important words are given higher weights. But just like bag of words, TF-IDF does not consider the context or order of words, and it has a higher dimensionality. Next slide, please. So after trying out more traditional models, we decided to use an advanced AI model, and we chose BERT for that. Unlike traditional models that process process the text sequentially, BERT reads text bidirectionally, so left to right and right to left, So it allows BERT to grasp the context and meaning of words more effectively. This makes BERT highly accurate for tasks like sentiment analysis and text classification, but it also makes it more computationally intensive. So what we did for the purpose of our project was to take the pre-trained BERT model and fine-tune that on our training data set, which is just the process that adjusts the model parameters to improve the overall classification performance. Next slide. This slide shows the results of the 3 approaches that we took on the validation data set. The validation data set was drawn from our original data set, but was never used as part of the training. So as you can see, all the 3 approaches have impressive performance. BERT and logistic regression have similar performance, which goes on to show that the complexities of the data set or its size and balance limited the potential of the advanced model that we could have gained otherwise. We also tested how efficient our model would be while generalizing to external data set. And for that, we use the ethos binary test data from Hugging Face. As you can see from the slide, that the performance for both BERT and logistic regression dropped significantly. This drop highlights the challenge of deploying model trained on one data set to another, especially in a nuanced use case such as hate speech classification, where the context and phrasing can vary widely. As part of our project, we also created a user-friendly Streamlit dashboard that takes in text as an input from the user and immediately classifies that as offensive or non-offensive or neutral in the case, as you will see in the demo. So future work, first, expand the training data to refine the model. So just add different data sets to enhance the model generalization and provide opportunities for refinement. Second, test an ensemble approach, which involves combining the predictions of multiple models to improve the overall performance. So we can just combine the predictions of logistic regression with either BERT or GPT-4. Third, hate speech detection models often lack interpretability. So one way to mitigate that is to integrate a GenAI response to give a contextual explanation of why a message was classified as offensive. And fourth is to examine the ethical implications of the model. So for instance, assess whether the model is specifically biased towards a particular group, or to understand the implications of false negatives. Last but not the least, we would like to thank our mentor, Nabanita, for all her guidance throughout the project, and the Women in AI Ireland community for providing us with the resources and support necessary to help bring this project to life. Thank you. Any questions?
Amazing work, Angela and Shubhangi, very much impressed. Yeah, any questions open to the public? Cool. Okay. Thank you so much. Just gonna bring back my screen. Is my screen visible? Yeah, I hope you can see my screen. Yeah, thank you so much, all the 3 groups. Incredible work, very much impressed. And yeah, we have almost reached towards the end of the event. So yeah, I just want to convey 2 things. So one is for the participants and the mentors. I have shared a feedback form in the morning. It'll be great if you can fill it out, and so that it will be really helpful for us to, make this better and improve in the future cohorts. And for everybody else in the call, if you're new to Women in AI, and if you're someone who is interested in improving your skills and maybe like also interested in mentoring and also, looking for networking opportunities, please do register in Women in AI and follow us. Thank you. And do you have any questions for us? Please shoot. Cool. Okay. Thank you so much for everybody who has joined today for your time. I hope everybody have enjoyed this session. And I think I'll give you back 5 minutes. Have a great evening. Thank you.
Thanks, Mika. Thanks, everyone.
Thanks so much.
Thank
Enjoy your
you.
evenings.
Thank you.
Thank you. Bye-bye.